So let us discuss a problem from Electrostatics and the book of Pathfinder. This is Check Your Understanding, question number 26. So let's get into the problem straight away. A parallel plate capacitor completely filled with dielectric sheet of thickness D and relative permittivity epsilon r, or that is the dielectric constant epsilon r, is placed on a horizontal tabletop. The lowered plate is glued with the tabletop. This one. The plates are of square and edge length L and mass of the upper plate is M. This mass is M and plate edge length is L. Each plate, this plate is a square plate. The plates are given charges plus Q and minus Q as I have shown in the diagram. Then the upper plate is shifted horizontally. Yes, this is it. Upper plate is shifted horizontal by a small distance x along its edges and set free. Find the time period of oscillation of the plate. Thickness D of the dielectric is much smaller than the edge length L. Thickness D is small means we have to neglect the fringing, that means effect, right? So now when you remove the let us draw the plate. Actually the plates are square plates, right? That is the edge of the plate is L, square plate. I mean the plates which I have shown there. Yes. Now this was the initial condition. This end is glued and now there is a small displacement x which is given to the upper plate. Now the upper plate will oscillate. Why? There will be a force on the upper plate, obviously. Just name the force as F. Why there will be a force? From energy standpoint we can say that obviously it is this is the lowest potential energy state of this system, and obviously this is a higher potential energy state. So any system wants to come to the lowest potential energy state, which is this lowest potential energy state. Now when it is displaced by x, let's work it out. Now when it is displaced by x, then the capacitor is only this part. This rest of the part is as if it doesn't exist, because see, there is charge on this part, okay, and charge on this part also. But as you know, this is a long distance, okay, so these two, it's a long distance. So wherever you find the capacitance effect only here in this region. So we have to consider the charge contained in this length L minus x proportionately. So in L minus x length, what will be the charge? In L minus n x length, so this part, the charge will be Q divided by length L multiplied by L minus x. And the same here. This will be obviously minus Q by L times L minus x. This much charge. And obviously now the capacitor plates we have to see. This capacitor plate, now I have to treat this width is L. Now this length is L minus x. So instead of L, it is L minus x because x part has gone. Okay. Now in this step, we will find out potential energy as a function of x, this small displacement x. U is equal to charge square. So charge is, as I have said here, charge Q into L minus x by L. So Q square by 2 times C. Capacitance is as I said, na? Oh sorry, this is not B actually, this is L, right? This is L. This is so L minus x times L. See, this new area. So A dash is L minus x times L. So there it is, L minus x. So I'll remove all where I have mistakenly I have written B. So this will be L cube there. So now I hope you understood this. This is the capacitance. So potential energy, as you know, the expression is q square by 2c. Now simply you have to just manipulate it a bit and do this operation, F equal to minus du dx, to find out the force on the plate. So F equal to minus du dx gives you this. Okay, so what happens now, I have chosen here B, so you just put B equal to L. Okay, and then you can solve on your own. Mistakenly I have put it B. I thought that with this B instead of L I have chosen, but it's a square plate, it's given. I missed out that part. So force is minus du dx. So this force comes out to be constant. So the acceleration comes out to be constant. So you write here half at square equal to x. Now what happens actually, this time period, see, this is the plate. Now this plate from here to x, now here it will come to, this is the stable position. So this here to here the time taken is t, and then obviously it will go to this side. Due to inertia of motion it will go to this side. So this is again the time taken t, and again from here it will become stable, stable equilibrium here. So this is again this time t, and from this stable it will come back to its actual position. There it is, displaced by x. So there from here again it is t. So it is actually 4 times t. That time period is 4 times t. So that's what I have done here. See, half a t square equal to x. Calculate t from here, and time period just put it 4 times t. And obviously if you substitute the values of this thing, acceleration, you will get these as the time period. Thank you.